A06, exercise A06 belongs to a category on its own. So far you have seen a lot of exercises that are meant to make you bump into an error so that you learn this error, you remember it well because you experienced it firsthand. You have seen exercises that are more of a drill type, making sure that you still remember your programming concept skills from your previous programming class, making sure that you can handle syntax, training to handle syntax and spot syntax error, etc. There are now a third series of exercise that we're going to discover with this one, and this series of exercise is there to help you learn to experiment, to toy with a programming language. The best thing you can do when you learn a programming language is not sit on your couch with a textbook. It's reading your textbook and having right next to you a computer with a compiler or an interpreter for that language so that you can test hands-on hypotheses that are going to emerge as you read the text. This is especially true for people in your situation. You guys have already learned to program and you have been already exposed to one or two programming language probably before this class. Well, now the job that you're doing in this class is learning yet another programming language. It's part of what we are trying to do. And part of this job is to learn how to leverage what you already know. So somebody that knows nothing about programming and reads a textbook has no clue. They are going to just tend to accept everything as, well, this is new, I don't have experience in programming, I'm going to accept every statement and move on. Okay? You are in a different situation. You already know about programming. So progressively, you'll see all along your career, when you learn new language, which you are going to do quite often, you will have constantly questions arising in your mind related to what you knew about other language. For example, is C having classes? Everybody that took Java or C++ before they come here has wondered at some point, well, what's the difference between C and Java? Well, C doesn't have class. C is not object-oriented. Oh, okay. Well, let me then assume that things are going to be different than Java or C++. Let me try to focus on what's new, what I need to learn. So this is how learning a new language happens. Okay, and this exercise is going to illustrate the kind of little program that most programmers write just to make sure they understand how a language behaves with respect to some specific property. Namely, in the case of this exercise, we are discussing about the logical AND and the logical OR operator. Both of them are characterized in C as using shortcut evaluation. What does shortcut evaluation mean? It means that if you remember the truth table for AND operator, you can have an expression with an AND operator true only if both operands are true. So let's say that you're trying to evaluate a given expression, okay, Boolean expression. You realize the first operand, the leftmost operand, is false. Do you really need to go and evaluate the right operand? Well, it could be as simple as a condition such as a less than 3, but it could be as complicated as calling a heavy-duty function, and then the result of this function will be true or false. Do you really want to do all of that work since you know already that there is no way, regardless of the true value of the second operand, that the whole expression will be true? Well, that's what shortcut evaluation are all about, okay? In the case of an AND operator, you start evaluating your terms, your operands, left to right. So you would evaluate this first. If this is true, you cannot deduce the whole expression is true. You need to figure out if the second is true as well. If this is false, however, you can already tell that no matter if this here is true or false, the whole expression will be false already. For the OR operator, logical OR, the logic is reverted. Okay? If you have a less than 3 or c less than 9, if the first one is true, you can already stop and say the whole expression is true, because it takes only one of the two operand to be true for our logical expression to be true. If this one is false, you cannot say anything. You need to evaluate the second one. Okay? So there are two concepts here. The first is, in a logical expression, operands are evaluated left to right. Second concept, the AND and OR operator have something called shortcut evaluation that allows them to take literally shortcuts in doing the work of evaluating all the terms of a Boolean expression. So here's what we're going to do. We're going to assume that we were told this by someone that is decently knowledgeable in C, but still, this person didn't reference us to any serious documentation, so we are not 100% sure they were right. How do we write a little program that is going to allow us to realize whether this property holds true or not? Well, okay. It's a good time now to pause and try the exercise on your own. I'm going to proceed to give you the solution progressively here. The hints that are given to you in this exercise are really critical. They are each giving you a little piece of the puzzle, and you need to make the effort to actually think about this and then try to piece them together to obtain your solution. The first thing that you are told is that printf, the printf function, returns something, actually. Most people just ignore that, or just most people don't know that, I don't know. But you can write something such as int count equal printf. Printf will return a value of type integer, which you can store in a variable. And then you can do a printf of this value to see what it was. And this is going to be the number of characters successfully displayed on the screen by printf. So this is an interesting property, very little known of the printf function. Okay, let's toy with it a little, and then I'll show you how you can use it. I am compiling my program, running it. I display ABC. I display the value returned by printf. It was 3. So that makes sense. Now, that means that printf is an interesting function because it has a side effect and it has a functional return value. What does that mean? Well, a lot of people in programming, especially people that love functional language, they are insisting on the fact that every function should return a value. For example, you call the square root function from the math library, it returns a value and does nothing else. This is extremely clean computing. It's almost mathematical computing, okay? You call a function, it returns a value, that's what it does. Now, printf is sort of a messy function, okay? It's not as beautiful as and clean as a mathematical function. Printf is called, printf will do something on the screen and then return a value, which means once you execute printf, before you get the value from printf, you have done a side effect, which is displaying something on the screen, and this cannot be reverted, okay? So here's the deal. We have this function here that returns something, an integer, and this function will display something on the screen before it is executed. Okay, let's have a look at the other hints that are given to you in that exercise. The second hint is, don't forget that in C, anything that is numerical, every integer, can be interpreted as a truth value. Therefore, the return of printf could be also interpreted as a truth value. Well, let's see how ugly this can get. What if I write if printf hi? Not doing much, just displaying hi on the screen. And then if the return value is true, printf is true. If the return value is false, printf, this was false, backslash n. And I'm going to move up here and add a backslash n here as well. Okay, so what is this program doing exactly? I call printf. I'm going to get back from printf the number of characters displayed on the screen. That's 1 for h, 2 for I, and 3 for backslash n. So 3 total. 3 is true. So this is going, the return value of this printf is going to be interpreted as a true value, which is going to lead me to execute this code here. Well, let's compile and test this. Go back to Conqueror, GCC a06, oops, little typo. Printf with 2t, yeah, that would have problem compiling. So let me remove 1. Save again. Let's try to compile again. Okay, now let's try to run this program. Hi, this was true. So here's what happened. Printf hi execute, because to decide on this conditional, I need obviously to call this function. This is what my conditional is, a call to a function. So I call the function printf. It displays I on the screen and returns. And it returns a value. 3 characters were displayed on the screen. So now my if statement boils down to evaluate if 3. This is what printf returned. 3 is different than 0. 3 is true. So I'm going to execute this line of code. Now, how can we use this? How can we leverage those tidbits of information I give you here to assess whether in a n, for example, logical expression inside of an if statement, parameters are evaluated, operands, are evaluated left to right or right to left? Well, it's a good idea to pause the video now and try to figure this on your own right now. If you're still here or when you come back, well, I could use several printf. I could use printf1 and printf2. Well, to evaluate this whole Boolean expression, I need to do what? Well, I need to start with one of those two operand, which are called to function, printf in our case, and I need to start evaluating one, decide if it's true or false, the return value, and in our case, the return value will be 4 characters here, 4 characters here, so that's going to be true, and then move on to the second one. But the order in which the printf are called is going to tell me the order in which the operands are evaluated. Let's try this. I go back to Conqueror, compile, execute. 1, 2, this was true. So that tells me a lot of things actually. That tells me that printf was executed, this one was executed before that one. So operands of an AND, logical AND operator are evaluated left to right. And it tells me that this one was true, but there was no shortcut evaluation. So I went on to execute that one. So that tells me part of the story, but now I would like to know if really the AND operator does shortcut evaluation. Well, to assess that, I would have to have this printf here return something equal to 0. I could achieve that by displaying an empty string, maybe. Well, it's not going to tell me then when it is evaluated because I won't see anything on the screen. Instead of that, I'm going to use a negation operator. So printf will execute printf1, and then the return value 4 will be negated. 4 is true, negation of true is false. Therefore, logically, my AND operator should not move on to the next evaluation. Well, let's test that hypothesis. Compile, run. 1 is displayed. Then I displayed this was false. What does that mean? 1 was displayed because this is executed. It returns 4. Negation of 4 is going to be false. False and, hola, stop there. My first term is false. There's no way, regardless of this, that I'm going to get a true. So I can stop evaluating here, shortcut evaluation. And this is exactly what happened. The 2 is never displayed, meaning that the second printf was never evaluated. What about the logical OR operator? Well, let me replace this by OR. This one is false. So logically, if this one is true, if the first operand is true, I should never see the second one. Let's test. Compile. Run. 1 is displayed, indicating that the first printf is evaluated. Because it's true, I never go to the second one. If I do a negation of my first return value here, I can then go here, compile, execute, 1, 2, this was true. So this little program allowed me, even if I'm a complete novice to C, allowed me to figure out exactly what are the properties of this language relating to shortcut evaluation, relating to the order in which operands are evaluated. And this is very close to what people like to call the scientific method, because we make hypotheses, we design experiments to assess the truth of those hypotheses, except that our experiments are not involving any chemical, they're just involving writing a program. Then we run those experiments. The only thing that's going to bite your ear with this kind of play is if you are not scientifically rigorous enough. You build experiment, the experiment is badly built, you think that it allows you to deduce something, but in fact, it could allow you to deduce many things. So this is why a math course, a couple of math course, or like any other scientific inclined course is going to help you build a sort of rigor that you can then apply to programming. But pretty much this code here is solving the problem we had to deal with.